So we previously made a discrete instrument where you pressed a button and you heard a tone, kind of like a piano. Now we're going to make an analog instrument where we read information about the world and we use that to translate it into sound and light. In this case, it's going to sound a little bit like a theremin. It might not sound great, but it'll be a lot of fun. So let me give you a demo. I've turned off the instrument momentarily. Oh, and let me allow you to hear it on the mic. And let's turn it off. So how does this work? Well, there is a photosensitive diode of some sort on this board that responds to light, and the CPX can sense that, and then we translate it into the number of neopixels that we light up, as well as into a sound. So let's try to make this. All right, here's the final code that we're actually going to use. So it's fairly simple, but let's start very simply and from the beginning. We're going to create a new project. And I'm going to teach you a few different things about these sensors first before we actually make the instrument. So the very first thing that we're going to do is to use input. And there's a variety of different kinds of input, like sound level, light level, ambient color. We're going to use the light level. And as you notice, there's really no place to put it in here, so we need to do something with that light level. Well, the first thing we're going to do is actually just print it to the console. So this is going to print the light level into the console, and of course, in the simulator, we don't have an opportunity of using real light, so they show this virtual light here where this is maximum light, so this would be a very, very bright room, and then all the way you can change it all the way down to 0, which would be a dark room. So we can do that, and we're going to output the light levels in real time. So let's see what that looks like in the simulator. So if it's really dark, the light level is 0 in the simulator. And if it's getting brighter and brighter, you'll notice that the light level goes up and up. Finally, this is full brightness at 255. So we can set it to like the middle. So hopefully that should be clear for you. Now, one cool thing that MakeCode has for us is it actually can turn this neopixel into a bit of a graph, kind of like a bar graph. So let's do that. You can search here for graph. And you notice it comes up right here. And in this case, we can just copy and paste the light level. And let's rerun this program. So now, as we set the light level, you see the number of neopixels that are shown correspond to that light level. And we go back to the simulator and do the same thing. And as we go up and down and up and down, the number of neopixels also light up. So perfect. So that's kind of cool within itself. Now, we can translate that as well into sound waves. And the way we do that is we're going to use music again, and we're going to play a tone. We can ring a tone at middle C, of course. So let's do that. Playing a tone at middle C. But we can change this to anything, because it's just a numeric value. So this is hertz. So like, for example, A will be 440, or that's 220. The octave up will be 440. So what if we had this tied to light level? Well, let's try it. So I'm going to copy and paste light level, and I'll throw it in here. There we go. Now let's try this. All right. can hear from about like 20 hertz to 20,000 hertz, and this is really on the low side because the light level goes between 0 and 255. So one thing I am going to do is I'm going to increase the pitch a little bit by dragging over this math, and we're going to add just like 300 hertz to it. So just 300, and that's going to raise the frequency and raise the perceived pitch. So let's try that again. Of course, you could set this to like 500. But for my own ears, 300 is reasonable, so let's just do that. And again, because we're working with sound, we want to just make sure that the volume is up on our CPX. So I always initialize it to 255 or whatever value I want. So let's not forget to do that. And then because working with sound can be a little bit annoying, the other thing that I want to introduce here is the ability to turn on and off the instrument. And so for this, we're going to use a switch. So there's this little switch here that you might not be able to see that you can toggle back and forth. And so what we're going to do is add in, if the switch is on or if the switch is to the right, then we'll play music. Otherwise, we won't. So let's set that up. And for that, we need to use logic. So if something is true, then we're going to read the light level and graph the light level and so on and play the tone. But rather than it's now in this case, it's always true. So we're going to flip this out to be that switch. So that's an input and it's towards the bottom if the switch is to the right. If the switch is to the right, then we're actually going to do this. So let's see. Let's try that again. Now the switch is to the left. All right, so the issue is that the simulator was resetting the switch to the right every time, and the sound was not stopping. So we have to have an else condition. So we can click this. We can say, if the switch is to the right, then play the music. Otherwise, turn off the sound. So for that, we can do music and then stop all sounds. So let's see how that works. There we go. So that switch, and it stops the sound. Perfect. One other thing is I always want to graph the light level. So not just when the switch is to the right, but I always want to graph the light level. The only thing I don't want to do is play noise if the switch is to the right. So I can also just always print out the... And this console log and graph could be on either side of this if block. So let's give this a shot. And I can turn it off. Okay, so we built our basic instrument. And so now let's actually download it to the CPX and play around with it there. As well. So I have the switch here to the left, so it's off. So I can move it to the right, and it'll immediately start playing sound. And then I can add in more light, and less light, and more light, and less light, and more light. And there we go. And let's turn that off. So we did it. We built a basic instrument. So have fun with all the different kinds of sensors like accelerometers and the sound level and obviously light level and other things, and you can really create some cool interactive experiences.